Good evening, everybody. Welcome to the YouTube Model Builders Hangouts tonight. Barry and Mike's MRR Tech Show, our live hangout presentation this evening. So I'm your host, Barry Rozier, and my buddy Mike's on board. Tonight we'll be discussing some of the upcoming tech trends in model railroading. We'll be talking about the new Bluetooth system that Bachmann has begun to offer. It's put out by a company called Blue Rail, and touch a little bit on some of the LCC stuff I saw up at Amherst this year, some of the first for-sale functioning hardware to use with LCC, so that should be an interesting topic to discuss. We'll be a little bit short tonight because Mike and I have to get ready to go to Boston tomorrow morning for our annual trip to the Fine Scale Expo, so I'm going to try and keep this to about an hour tonight, so see how it goes. And do not forget that YouTube Model Builders is your source for free model railroad resources. We have our fine online free magazine, and JD and the team knocked it out of the park this month with the whole episode, or the whole issue on signaling and everything, so definitely download your copy, go to the website, youtubemodelbuilders.com, and click on the eMag on the right and subscribe so you can get notified whenever it becomes available. And then on Tuesdays and Thursdays, we have our live chat and presentations on the Hangout, such as we are in here tonight. And join us every month live for the YouTube Model Builders live show with myself, Bill Graham, Big Bill, and a host of guests. So I'm hoping everybody enjoys this evening. So how's everybody doing tonight?
The questions are too hard, Barry.
What questions? I'm going to be making this up as I go along as usual.
That question was too hard. How's everyone doing?
So, to get started, when I was up at Amherst with Mike this year, I got to sit down and talk with Ken Cameron. He's one of the JMRI developers, and he actually got to show me some of the stuff that Dick Bronson of RR Circuits is developing, and some of the stuff he had for sale there that's LCC related. And just for a little digression, LCC is the new approved standard from the National Model Railroad Association called Layout Command Control. It's essentially like DCC, but meant for signaling, detection. It's all for the aspects of DCC that we put on our layouts. So, I mean, it'll definitely be something that we're all interested in, going down the road, because as we add more and more things to our layout, the DCC bus is getting a little bit on the overloaded side. So it's about time that they've done something like this, for everybody to use. Got my pretty picture up there now. So what the people at RR Circuits have done. And I don't know. You saw some of it too, right, Mike?
Yeah, they had a lot of neat stuff there. That's for sure too. And I think basically there's at this point we're on the bleeding edge of the LCC, and as more products come out, you'll see more and more people jumping in. But I mean, the point you made is very valid too. That right now the DCC bus is meant to control locomotives, and it's been had all these add-ons just piled on there, and it's overwhelmed at this point. So it makes sense to basically replace it with an alternative bus. I mean, I guess a poor man's way to do that would be just to have two DCC systems running, but
you can do that. Yeah,
you can certainly do that, but this is actually more geared towards animation and static decoders and and controlling everything on your layout. So you'll have basically DCC for, you know, your locomotives and your moving items, and LCC would be for your signaling and your lights and stuff that doesn't move. You know.
Yeah, this is true. Now, what I've seen so far is the basic pieces that are available through our circuit. Dick Bronson has engineered control nodes for the system. So you have power supplies and control nodes that build the DCC or the LCC bus, and so they're the basic control interfaces, and then we have a USB connection that ties into JMRI on the computer if you want to. I mean, LCC can operate on its own without the need for a computer. That's another aspect of it. But what he's done, he's designed very basic control nodes right now, and they are equipped with connectors where you can plug in his signaling components, such as the Watchman, the Towerman, all those different boards he has, so that you can build a functioning signaling system. And it is all functional now, because I saw it live at Amherst. They had a demonstration layout, and around the perimeter they had LCC nodes in the bus connected. It's running, I think, on RJ45 regular Ethernet cabling, and then plugged into the LCC control nodes are the standard boards that Dick currently sells that work with DCC. He just adapted the connector that connects them together and put that onto the LCC control node. The thing was working fantastic. He has the detection boards plugged in, you have signal control boards plugged in, and as the locomotives ran around the layout, you could actually see the signals working in real time, just like you would want it. Now, the plan going forward, since this is all very first pieces out the door, is to, rather than have to buy a control node for every device you need to plug in, is that the functionality of the control node will be combined with, say, the Watchman board or the Towerman board, and that there will be a one-piece device that will plug right into the LCC bus. Now, the LCC bus is actually based off of what's called CAN bus, and everybody, you've never seen it, but CAN bus is in every car we own. All the computer infrastructure and sensors and everything in your automobile are communicated through CAN bus. And the NMRA, some of the working groups they were working with, and the OpenLCB group took that standard for communications and adapted to this design and just wrote the software layer on top that has all this functionality. So I think it's a definite step in the right direction. It's got a lot of bandwidth. It can handle a lot of capacity as far as signaling and all the commands that go back and forth. Where on a really large layout, like Mike and I both said, your DCC bus can get crowded, and what happens is you get signal latency. And you send a command to your locomotive, and it doesn't respond immediately like it should because there's too much traffic over the wire. LCC helps take all that non-control traffic and put it on its own system. And like Mike mentioned, you can do that by having two DCC systems. Like NCE guys might use a LocoNet system to do signaling. But now they wouldn't have to, and you don't even have to have a computer to do that with LCC. It's going to take another year or two probably for really functional products to come out. And I'm definitely keeping my ears open as to what's going on because I want to learn more about it myself. And every year at Amherst, I make sure I go tap Ken Cameron on the shoulder and talk to him a little bit about what's going on, so I keep myself informed about it. I mean, I have to see if there's a Yahoo group for it yet. There probably is. So Mikey, I mean, what's your thoughts on this? I mean, where do you see this thing going? Do you think this is going to take off like everybody's hoping it will?
Well, I mean, it's too early to tell right now. I mean, we're on the bleeding edge, but uh, the fact that they're considering things like tracking the locomotive, having detection. I mean, that's a crucial component. I mean, that's something that the current DCC system really doesn't do too well.
No.
The fact that you don't have to use a computer to control it, that's kind of a nice feature as well. A lot of people aren't like us. We're just happy to hook a computer up to it and
Yeah.
just go wild with it. Of course, you and I would do something crazy like put a webcam in the locomotive and stream it on the internet or something stupid.
What else? You're going to call that crazy after what we saw at the RPM meeting?
Well, yeah, that's where I was going to go with this too. I mean, the whole idea of using JMRI to do virtual signaling, I thought that was incredible. That little
Yeah,
demonstration.
that was fascinating. We'll look to touch on that a little bit tonight. Yeah, we actually saw this one guy did a clinic. Actually, what was his name, Bob Buckaloo?
Yeah, I think it was.
Yeah,
Yeah.
yeah. If you go into JamRi's website and want to learn about Panel Pro to do control panels, the whole tutorial in there is from the Quaker Valley Railroad. It was created by this guy, Bob Buckaloo. Well, he did a clinic showing how he did virtual signaling in JMRI. And you need no physical infrastructure on your layout, if you want to put automatic signaling in, you would need detection as all. You don't need any physical signals on your layout. And what he did is he's using the web panels that JMRI can put out, and he's taking a photograph. Well, that's what he did. He took a photograph of a signal bridge, say, or a signal mast, and then puts that as a background for a panel in JMRI, and then puts one of the signal icons where it would be on the mast or on the bridge, and then sets up all the logic. So as you're going around the layout and coming to another, say, control point, you just click the links between the panels on your tablet or your phone, and now you can see the upcoming signals because the logic's there. It tells you whether it's restricted, approach, medium approach, whatever you decide, and then you can actually see their signal on the board in front of you in your tablet, but there's no signal on the layout, so it becomes truly virtual.
Yeah, I think the most important thing there too, Gary, is if you're not sure where to put signals, this gives you an opportunity to try it out, run some operating sessions, see if it works out, and if it works out, put a real signal there, and if not, get rid of it.
I think that's a very valid point, Mike, because, like you said, you can use this to plan a signal system and see how it would work. And I mean, we both use phones for throttles and everything, but I tell you what, you mean a Digitrax UT4, which has limited functionality, it's like $60, $65. Pretty much anywhere now you can find a 7-inch Android tablet for like $50. If not, wait till Black Friday. You can get them $40 to $50. You don't need much. You don't need a high powerful one, but Engine Driver on Android, which works with the Y throttle and JMRI, does do the web panel piece a lot better than Y throttle. Because you can actually set it up to split the screen, so you have your throttle on the top, web panel on the bottom, so you can actually pull up the CTC panel, control your turnouts from it, and then there's ways in JMRI to put a link on that image, so you touch the link and it'll bring up the next panel, and you can put information on the link saying, yeah, this is going to CP25, say that's your control point for an entrance to a yard, and then that way you can swipe through the panels like that by hitting those links and come up to the control point you're coming to, and then see the actual picture of the signal mast or signal bridge, and then the virtual icons of what the signal positions are. which can be controlled through, a properly designed CTC panel, or if you do block detection and automatic control, it would actually show based upon that. So it's rather an interesting concept because, like Mike said, now we get to proof out should our signal be there. Do we need a signal there? I mean, so you can actually try it out. And what this guy, the friend of Bob Bucklow's, he was on the layout tour. Unfortunately, we did not get to see him, but he lives near Mike, so we might at some point. He's going even one step further. He has, like Mike said, he has a webcam on a car on the layout that runs around. And then he did this layout above his garage. Below in the garage, he has built a full-size SD40 cab with a with Pi Engineering full-size AAR control stand, which is all tied into JMRI so that it works the locomotive controls from the real controls. And then he put a big screen on his garage door, and he has a overhead projector in the ceiling that projects an image of what's coming from the webcam on the track. And then he actually gets to operate the train from in his cab. And then because of the virtual signalings, he just has to flip through the panels, and they can be displayed on that screen so he can see the approach and control point and see what they look like. Realistically, he could put a tablet inside of his locomotive cab that he could do the same thing with, and all he would see is the real-time track image out the cab window. But the panel, say like a display in his locomotive, would show you the next signal coming up.
Right.
So he's got some interesting ideas.
It'd be like
way too much money and time.
Mm-hmm. Yeah, it could be just like cab signaling. And what's really interesting about having a full-size cab somewhere else is if if your layout's tight for space, you don't have room, or even like somebody's disabled, perhaps. You could set it up so that the cab's handicapped accessible, and someone who's not able to go through the layout proper could go into the cab and still run trains with you.
Absolutely.
So it opens up a whole world of possibilities.
Yeah, I mean, literally, some people have taken, that when you build these control panels in JMRI, you can actually put web components on there that let you control throttles and such. So you can actually build a panel that will allow you to control a locomotive. Thus, if you publish that through your router out to the internet, I could go to that web page and control the locomotive on your layout 1,000 miles away from you. I've never tried to do that, so yeah, Chris.
Quick question. Have you ever tried? I've tried using those web panels, and I get a serious latency. Have you noticed that at all?
I have not played with them myself, Chris, but I would imagine you would if it's over the internet. I mean, maybe internal to your house or at a layout or a clubhouse or something. It might not be an issue, but I imagine latency might be an issue over the internet.
I just do it on a home Wi-Fi system, using a tablet to throw turnouts on a layout panel, and sometimes it doesn't refresh for 5-10 seconds or more.
Yeah.
It'll delay, but from the time you hit it.
I've noticed that because I have virtual CTC panels built for a little demo layout I set up at train shows and for our big club layout, and yeah, that happens. You get a little bit of latency, so.
Is that you?
Yeah, that's my idiot dog. The one dog's heard in that part in the front yard, decided to go run downstairs, and the big dog barks. It's like remote control. There you go. That's a girl.
Sounds like it's wheezing, dude.
Well, you ought to hear. She sounds like a locomotive. I'm going to record her one day.
That would be.
So I mean, there's a lot to be said for where LCC can take us with all this, and and I think it's still not a bad thing to combine it with JMRI, and thus it gives us all kinds of possibilities for control of our layouts. Like I said, we can even say, I mean, there's clubs that have done virtual operating sessions. You know, the operators aren't even in where the layout's at, and they're controlling trains. They can see an image from a camera in the cab of the locomotive, and somebody's there to tell them where to spot cars or whatever. But there's so much you can do with that.
Well, I mean, that's a good idea. You could actually cut your train crews in half. You can have your engineers off site and your brakemen just following the train around.
Yeah, exactly. I mean, that would work great. I mean, it depends, but I mean, where I don't like that concept is the fact that model railroading, a lot of hobbies, is a very social hobby. That's why people build these big layouts, invite their friends in, and then, you know, we all have fun together doing it. Just like, you know, us hanging out here, you know, it's all social. So, but if you set up the right system and put, like, say we use, like, you know, cameras like this and talk to a dispatcher with using Skype or Google Hangouts, I mean, you could still have some of that feel of the social side of model railroading, and yet still do the virtual side of it as well. I mean, it'd be an interesting experiment to play around with that. Then once you get one of us gets some sort of a layout in our basement, like, hey, we'll have to play around with that.
Yeah, that'd be pretty cool, actually.
Yeah, I've got
Question.
friends that sometimes can't make it to op sessions as much as they'd like to be here, and if you could let them do dispatching from home, you know, they have to stay home and babysit. Gives them something to do while they're at home and still participate in the op session.
Oh, you're absolutely right there. And if you publish the CTC panels, it's very easy to have a remote dispatcher. And then you just need a method of communication. You know, you could even text each other information over your cell phones, or, I mean, I keep meaning to talk to the guys that have created Y-Throttle and Engine Driver to say that they should put some kind of communication system in there that would work over the Wi-Fi, so that I could pull up a screen where I can, you know, dial the dispatcher and talk to them through the tablet or phone I'm using, you know, as a method of communications. But I have never got around to doing that, just an idea in my head. But who knows? I mean, they might be able to do that. So I always thought that would be a cool thing to do, you know?
I got a question.
What's that, Joy?
LCC. So for those of us that don't know much about electronics as you do, for the simple operators out there, you would need a separate power supply for that system? Is that what I'm understanding?
Yes, every so many control nodes you would need a power supply. What that does is control nodes boost and repeat the signal that goes on the communications bus. I mean, they're little wall warts, they're not really big, expensive power supplies.
Mm-hmm.
So you would have your primary interface, which is the part that you, if you want to, can plug into a computer. And then each control node can control so many devices. And every so many control nodes, you would need a power supply on the bus.
Okay.
But other than that, it's not, you know, not like you need a big, massive power supply to run the whole thing. You just need little spots for wall warts every so often.
Sure, that's simple enough. Well, then would that free up your DCC system for get more power to run local sound and all that?
Yes, it will, because as every decoder you plug in, be it like a locomotive, or if you plug a stationary decoder in that operates your signals or operates your turnouts, that draws power from the bus. Mm-hmm. Not a whole lot compared to a locomotive, but still, say you got, you know, a 5 amp system and you're running 3 or 4 locomotives, but you got, like, you know, 50 signal control boards and tons of signal heads. Mm-hmm. Yeah, it's going to eat up capacity on the system. Mm-hmm. Most of those boards do have the capability of their own power supplies, but some can be powered directly from the DCC bus. So doing LCC is probably a better way to get as much as possible off that narrow little DCC bus.
Is anybody running one right now that you know of?
I don't know anybody personally. There is a function. There's, like I said, MRR Circuits, which is Dick Bronson's company, they are selling the components right now. So they have a functioning demonstration layout that they've taken to train shows. So if you get to probably some of the bigger shows like the National Train Show or Amherst, you will see it there. That's where I saw it. And yeah, it's like 4x6, 4x8 size layout, and then he has all the control nodes in little clear plastic boxes around the outside of the layout. And yet everything's just plugged in with regular Cat5 Ethernet cables that can make him communicate. And then he has the main head, which has the interface to the computer so that you can get signal feedback if you want to do CTC, which you don't have to. So, I mean, it can be done fairly simple. Like you can literally put in an automated signal system by using LCC control nodes and detection boards and signal boards, and just it's pretty much you plug it in. You need the USB to be able to hook it to your computer and program the settings. And then when that's done, you can unplug the computers, and the signals will work based on the detection of the locomotives. And you don't need to have CTC dispatch. You don't need JMRI driving it. You've set up all the logic right inside the control nodes. So I hope that answers your question, because I think that actually, yeah, I think that eventually is going to work its way out and be a lot, nicer for people to, work a signal system when they don't want something that's highly complex, like putting in a DCC-based system.
Yeah, I mean, as long as we can keep it simple, and I think the whole basis is that basically it's like daisy chain. So if you have a board that's upstream, it passes information to the next one, and then the ones down there. So
Yep.
it should be fairly simple to wire. And
It actually is, yeah.
It's just like kind of plugging in a computer or a telephone. It's really simple.
Yeah, and the last node in the chain has to have a terminator plug put in, but that's pretty straightforward.
Mm-hmm.
So, I mean, it's basically like any kind of communication system. But this is nice because you don't have to have all kinds of crazy wires, custom cables, buy off-the-shelf cables, which is nice. So now, let's talk a little bit about Bluetooth and Bachman's foray into this arena, which I hate to say, but I'm almost disappointed that it was Bachman that did it first.
Yep.
But I think Bachman saw the writing on the wall that people like us are starting to use these to run our trains, and every kid in the planet has one of these in his hand, and why not take advantage of that fact? So the company Blue Rail created the hardware. Once it got to a point where it could fit in engines, Bachman, signed the agreement with them, and they've begun selling. Right now, I think the only units that are available are F units, and that is because of the size of the control board that goes inside. So it plugs in via regular 8-pin DCC connector, standard NMRA 8-pin connector, or it can be hardwired. But the board is 28 millimeters wide, so it's not going to fit in a narrow hood unit yet. They are working on making it smaller, but two advantages of it is one, you can do just like DCC, just put a fixed voltage on your rails. But in this case, you just need a standard DC power supply that puts out this fixed voltage. Or it has the connections to use a built-in battery. So you can put a battery in your locomotive, plug into this board, and there's some circuits you can add so that you can pull it onto a track that has power, and it will charge the battery. It's not built into the board yet, but they give you the information so that you can actually have a power track where you run the locomotive onto, and that power will start charging your battery. So it's feeding into the dead rail society people, so we don't have to have immaculately clean track work and everything. The locomotive will work on battery power. I don't foresee that taking off as a big selling point of the Bluetooth connectivity and control, because frankly it takes up too much room in the locomotive. But if they get the board small enough and they get good enough lithium polymer batteries that are small enough that have enough capacity to run for a couple of hours, then it could reach a threshold where it might be very viable for people. And the plan is going forward is to be able to add sound in. So I would like to see the companies that sell sound decoders and stuff to maybe try adopting this technology and license Blue Rail's thing and try and develop a system with them where it has a quality sound we know now, but has this Bluetooth control. Because you can buy a board from them soon. I think next month the Blue Rail boards go on sale, or you can buy a Bachmann locomotive now, and then you can either use Bachmann's Easy app or the Blue Rail app, both which I think are free, and then you can control any of the locomotives because they all use the same hardware inside of them.
Mm-hmm.
So I'm thinking me and you need to get a couple of these boards when they go on sale from Blue Rail, and I can play with them.
We do, Barry. And you know what? In all honesty, I don't really see this as a real challenge to DTC, but I do see it as a good entry point for people who started in the hobby, especially younger kids who are used to using their cell phone, without having to invest in DCC equipment and figuring out DCC and the ins and outs of that. It basically is as simple as the old school train set, we got like in the 70s or 80s. You just plug up the power tube wires, boom, and then you go with it. I think that's the audience for that. I mean, if you look in terms of Bluetooth as a transmission medium, it's a very short range protocol. You're not really you're not going to really go too far with it. So once you start expanding into bigger room size layouts, you're going to hit dead spots, etc. Certainly, if you wanted to do radio control, that certainly would be a better alternative. And I actually think that's more mature technology, and the radio boards the receivers and transmitters are a lot smaller.
Yeah, you're right there. The stuff like the DRS system that Tam Valley sells, that is because that's a much more mature technology now, and it uses DCC style commands over the radio, or DCC commands over the radio, so it's compatible with our current technology, and it can work on track power or battery power. So I mean, that's all part of their dead rail system.
Yeah. So yeah, I mean, I see this Bluetooth as basically a way to get, Junior with his first train they can run with his phone without really investing in the DCC.
Yeah, I agree with you there, Mike. Literally, if the simplest method of will be literally put together a train layout with DC power pack, and what I'm thinking, 12, 14 volts, whatever they put in the rail, and then you're ready to operate. Very, nothing complicated about wiring unless you're talking a reversing loop. So for a basic train setup to get the kids interested and everything, like you said, you plug in the power pack and put the locomotive in the rails, pair it with your phone, and you're ready to rock and roll.
Right.
And it's a lot cheaper because the application is free.
Right. And the thing is, if he plays with it for a year or two and he wants to get into it, then he goes into DCC. And if he's tired of it after a year, you're really not out that much bucks.
You're absolutely right, and I think that's think that's where we're going to see this thing take off a little bit. That's again just like the LCC. It's a, it's still new. It's right out of the gate. So let me see how Bachmann adapts this to some of the smaller locomotives. It all depends upon when Blue Rail gets new hardware in development, and we all know that takes a long time. So.
Well, and they want to grow it, and there are some ways to make Blue Rail interesting, like if you had JMRI speak directly to Bluetooth hardware in your computer, centrally located, and then and use Y-throttle. That might be of interest. The guys doing Blue Rail have all these grand dreams that it's going to scale to the size of large layouts and everything. Personally, I am fascinated by JMR or by Tam Valley's wireless DCC, but the FCC has almost made that impossible to actually grow that into a commercial product. However, my last comment is LCC, that is going to be a hit. Undoubtedly, LCC will be a hit, and I'm holding for a year on my signal systems because actually I'm not even holding that long. I'm buying LCC hardware within the next few months. Yeah. I am going LCC.
Well, here's a comment from our good friend Muskoka Steve, and he says, I think that the problem with LCC is, like we discussed, is the programming. The logic in JMRI is much more advanced and a lot easier to program on screen, which is the one advantage of JMRI. He's right. I mean, you can go in and graphically program and set up parameters on menus and everything. Program this. It's not there with LCC until JMRI has all the setups for the boards and everything. Then I think that's where they say, oh yeah, you don't need a computer, you don't need JMRI. Well, you do need a computer to program it. And right now, without support of JMRI, it's difficult to program. He's right.
I think just to qualify that a little bit, Barry, LCC gives you the opportunity to not get involved with computers, but also allows you to get involved with computers, JMRI. So it's a little bit more flexible, but in those terms. But the other thing to consider is that this hardware is smarter than your normal DCC hardware. It's more interactive, some feedback. And so now, instead of having a network where it's basically unidirectional traffic, you tell it what to do, you have like this bi-directional, and you can do like distributed computer, where you basically give an instruction, it basically goes out, the board goes out, does its thing, and then reports back.
Yeah, and it's simpler, and it's lighter weight, and it's ultimately and electronically, it's easier to implement. Programmatically, yeah, there's got to be some effort on that front to bring that down to mere mortals. But electronically, it's simpler than all the things that are required for occupancy detection all the way through signal management, etc., electrically, hardware, and understanding those things. LCC massively simplifies and reduces the size and complexity of the on-layout electronics.
Right. Yeah, where that comes into play, Andy, is the fact that it's all standard now. If I want to go and configure a signal system right now, I can go to our circuits and buy all their components. Or I can go to Digichat, buy theirs. I can go CMRI, buy all theirs. But everyone's different.
And now, it's modern. It takes into account a modern technology. It's almost Twitter in that there's a publish-subscribe method here. Mm-hmm. So one thing can publish information, and subscribers, many, can subscribe to that information and do something, like a signal or a turnout can subscribe to that and can change its aspect based on information. What I find invaluable in LCC is that it was designed for a one-to-one, one-to-many, many-to-many, that kind of relationship. The problem that we run into with DCC is it was designed for a one-to-one relationship. And we're having to put JMRI in the middle of that to kind of become a splitter. And look at all the complexity when you put a splitter on your HDMI on your TV set. Figure out what input you need to be on.
A good way of denoting that is because JMRI becomes the traffic control cop.
Yep.
In that case.
But LCC has all that logic built in, So all these things and all these things can talk to each other directly, even though many things are talking, and the bandwidth is there to support it. And even though with all that complexity, it's still simpler. I'm fascinated by LCC.
Oh yeah,
I
definitely.
am too, and I think it's something that I'm going to have to get some hardware to start playing with. But I'm just wondering here, rather than JMRI supporting this thing, because realistically, you don't need JMRI to make it work. The logic is now in the control nodes. So why can't someone develop an app, being as this is standard, that allows you to program graphically your LCC system? Eventually, I'm sure the JMRI developers will put the XML files together for the definitions for all these boards as they come out, and you'll be able to do that in JMRI. But if you don't need JMRI to run the logic, why can't we just have a simple programming software that because there is a USB interface to LCC, plug in your computer, fire up this software, select your control node, set the logic on it, you're done. And then you can unplug the computer.
Have you seen Railstar's solution? It's they're building an entire DCC system. Right now, all they've got is the LCC interface and the LCC endpoint module and a DCC booster. But they're building an entire system that was designed around LCC support from the beginning of its design. And it's small and it's simple. The whole DCC system is just a Raspberry Pi, basically. I've preached that's the way to do that for a while. I mean, I've got a Raspberry Pi running JMRI right now. Runs great. And that's all their system is, and it's dirt cheap.
Interesting. Railstar, right? I'll have to look
And they have commercial hardware today. You can buy LCC USB interface and LCC endpoint nodes now.
Yeah, but what do those endpoint nodes do? Because I know, like, what Dick Bronson does is the endpoint nodes plug his boards, his existing boards, plug into those endpoint nodes to give you functionality.
Yeah.
I mean, Railstar's boards, do you have to? Is it the same thing, or are they like you buy an endpoint node for detection, an endpoint node for signal control?
No, it's got inputs and outputs on it. It's based on Arduino. You can buy it two different ways. You can buy a dedicated board that's designed by them as a whole, or you can buy an Arduino Shield. But it has inputs and outputs, so you can do signal driving, turnout driving, or occupancy detection inputs into that board, and then program it however you want to. And in theory, endpoint nodes become generic. So it doesn't have to be turnout or signal or whatever, just an endpoint.
Gotcha. Peaches, get over here.
That's a good point, because the thing is, if you make it open-ended like that, it gives you a lot more flexibility, but it adds to the complexity. So that it's always a trade-off when you design a system. So.
Oh yeah, and it is absolutely. This is such a contradictory conversation. LCC and Blu-ray are the far ends of the spectrum from each other. I mean, Bluetooth I agree wholeheartedly right now, and I don't see it actually growing outside of that, but I know they have dreams of that. Bluetooth is going to replace the DC power pack. I completely believe that'll happen. For the guys who have a circular track on the dining room table, perfect. For the guys with big layouts on the far end of the spectrum, LCC makes all the sense in the world. And for everybody in the middle, we're going to be doing DCC like we have been for a long time.
You got a good point there, Andy. I mean, we're, like Micah said, we're at such at the bleeding edge of all this new technology. This is almost like back when, like, the CTC 16 came out and DCC was first pioneered. We are kind of at that point in the hobby again, where we have so much new technology that's going to change the way we do things. I don't know that we'll change for a long time how we operate, like you said, real large-scale hobby layouts and everything. Smaller layouts, small room layouts, the Bluetooth eventually will become a viable control method. But at that point, then you can use a straight LCC system to run everything else, and you just use Bluetooth to run your locomotives, and you have a DC power pack plugged into your rails again. So it's an interesting time. And so I need to get my hands on some of this hardware this summer, and
It's a great time.
demo stuff.
It's a great time if you don't have your layout set up yet. I mean,
Yeah.
if you have your signaling system set up, you don't want to bother with LCC because you're already set up. But if you're just starting out and you have something that you're standing up right now, I mean it's great. You have a lot more options right now, and I think that's where LCC is going to really gain traction, is as people start going from the circle track to the room size layout, starting today.
Well, I think where
right.
Dick Bronson's got a good idea is that he's going to build LCC nodes, endpoint nodes, that have functionality already in. So rather than having to program all the I/O, like Andy was saying, that it's got output and input pins. It's already defined there, and it's already set up so that it knows that these are your signal outputs, these are your detector inputs, and you just get a control node that does that, and all the logic is set up for you.
Yeah, exactly. You want to keep it simple for someone who could go into the store, buy an LCC board, and use it right away instead of having to figure out how to program it.
There's a beautiful thing about it supporting a little bit of a scale of things, in that you can buy LCC and somewhat just use it. That's going to be the goal, and it's not going to have market success unless they get it there. But for people who are a little bit programmatic about things and that can do a little bit of Arduino programming, with LCC and Arduino, you can do a tremendous amount of intelligence on this $10 board. And it's not dependent on JMRI, or it's disconnected from it, or it's distributed from it, but so much detection and logic can be done on this. And if you have a module or a shelf layout, that is all you would need. Period. LCC.
Do you have something you wanted to say, Chris?
Yeah, I was just going to say, to Mike's comment, he's exactly right. I mean, this came along at the perfect time for me because, I'm a year or so away from starting to set up block detection and signaling, but I've already been investigating, and I just came to a dead end with everything I was looking at because I'd like to avoid proprietary wherever possible, and this LCC is just perfect for me. I can't wait to see all the stuff start coming out.
I imagine.
And perfect timing. I'm at the same point on my layout, similar point as you are on yours. I'm roughly a year away. If I had started 2 years earlier, LCC wouldn't have been on the roadmap soon enough.
Yeah, the only thing I've got going so far is the Tam Valley servos, and that's not going to be affected by the LCC. That'll, probably complement. The LCC will complement it. But I still hadn't made up my mind and wasn't happy with any of the block detection or even the signaling. You get a piece of this one is good and a piece of that one is good, but I haven't found a vendor that had everything all together in one place that wasn't too expensive.
Well, yeah, that's the thing, is they're all expensive, and like you said, like
proprietary is a full
circuits might have a great signal driver board, but they have poor detection, and I don't know that to be a fact, but like everybody can be a little bit of this, a little bit of that. At least with LCC, it's all known standards. Where it's going to shine is when people take those control nodes, the endpoint nodes, and give them functionality so that you don't buy this board and then say, okay, well, I got to assign these inputs and outputs to do X, Y, and Z. I buy a board that's already set up to do that. It says here's the common, here's your different signal outputs. If you want to control a turnout from that, here's your output to the turnout. Here's your feedback from your turnout, and then it all plugs into the bus. And if you want to have CTC panels with JMRI, you plug it into USB. The world is happy.
Yeah, and for an NCE guy like
goes, LCC is a ratified standard from the NMRA, if you buy into NCE, which they're not going anywhere, or Digitrax, and they're not going anywhere, but if you buy into some of these other companies, and the one guy who runs that company gets hit by a bus, all your money that bought all that hardware, you're not getting any more of that. With LCC, it's a ratified standard. So,
Well, and you know, Digitrax has its LocoNet, which was the best thing going until now. But for NCE, we had nothing other than to go ahead and set up a LocoNet. So now you're buying, you know, your bits and pieces, a little bit of this from this guy that plugs into a LocoNet, and a detector from that guy that plugs into your LocoNet, and it's all bits and pieces. Now at least it can all be bits and pieces with no worry about not playing with something else.
Yeah, that's the big advantage I see here, because just like we have the DCC signal that goes out over the track, that is standard communications protocol for anything DCC related. Accessory decoders, signal driver boards, not so much detection, but locomotive decoders. Now LCC is taking that same concept and put it into a common format for the things we need to operate our layouts, such as block detection, signal control, turnout control.
So I saw a video from the national meet, you know, out in Portland or wherever it was, that it looked like they had throttles from all different systems, NCE, Digitrax, MRC, all connected to the same loop of track and all running the locomotive without all the different systems. Is that true? Is that
Yes, they do.
we have to look forward to?
It's not a box that's currently available as far as commercial hardware, but yes, that was demonstrated. And
So it's just a matter of having somebody write a card that you would plug into a node to get you onto the bus, and then away you go. Is that pretty much how it works?
that standard, that part of the standard, locomotion control, has been written by the Open LCB guys, but has not been ratified by the NMRA yet. So it's not part of the standard for hardware development, or it wasn't a few months ago. They're close, and they're going to ratify it. It's just a matter of time before we get that.
Yeah, 'cause how nice is that? Bring your NCE throttle to your friend's Digitrax layout, or vice versa.
Unbelievable, yeah.
Exactly, yeah. I mean, I think a lot of us are going to look forward to that aspect of it. But like you said, that was all a function of the Open LCB group, which is a lot of the pieces of what they developed. They worked with the NMRA to build LCC, and the NMRA also had the NMRA net, which all that was melded together. Most of the componentry in the software design came from Open LCB.
And they're still around. OpenLCB is still the working group for, OpenLCB is the working group for the protocol, and then as they develop into hardware, it becomes part of LCC.
Yes.
So all the really advanced stuff that you would have to build the hardware for yourself will come first from the OpenLCB guys, and I've been paying attention to their mailing list, and boy, those are some slick fellas.
Mm-hmm.
Yeah, they are. I mean, not to say anything against the JMRI developers, but these guys, you know, they're all software guys for the most part. The OpenLCB guys are hardware and software. They're really, you know, great engineers to develop that thing. And you think about it, if you have the electrical and communication spec for an Digitrax or NCE throttles, what's the hardest part is that you need a circuit in between that will translate the equivalent commands to OpenLCBnet, which is what becomes LCC commands. So that's what they did. They built this custom box that I can plug various throttles into, and it becomes a translator. And then the backside of it, everything's now the NMRA standard as far as how that goes out to the devices on the track and on your layout. So if people start selling that hardware, or I can say this box, because most of the connectors for the throttles are common connectors, so if you can program that interface to say, I'll use Digitrax throttles or I use NCE throttles, that device there will open up a whole world of possibilities, because then if I like the DT402, I can buy it and plug it in. Me, I like the simple throttles like a UT4 or this. But a lot of people love their throttles. I know a lot of people love NCE throttles. So it would be great to see a device like that you plug into the LCC network and use whatever throttle you want, or even they sell a module for NCE or a module for Digitrax. You know, because then I imagine you could plug in and put different jacks for different throttles around your layout if people want to do it that way. You know.
Well, imagine the manufacturers that can come out and just make a throttle. Make a throttle for a steam locomotive that emulates a backhand where you actually do steam pressure, or you know, I mean, the options become very widespread. You do not have to become a major manufacturer and invest millions to be able to build an entire DCC system. You can just come out with a Kickstarter project for a custom throttle.
Hey, you have a good point there, Andy. A question I was just trying to think of things I was just thinking of. As far as the specs for LCC, we know it has, you know, bi-directional communication. Is there any plans for that to be able to have bi-directional communication with, say, a locomotive?
They have, to my understanding, they have shied away from replacing locomotion control of DCC and rather just layering on top of it with a control layer. But my understanding is they've shied away from replacing the decoders that are out there in locomotives. I think the greatest future that we have for bidirectional locomotive control is the British adaptations of the DCC standard that have been incorporated by the British. What is that British? What's the British equivalent of the NMRA?
You might.
Anyway, those guys have been working to ratify the standards around some of their manufacturers' decoders. You know, RailPro or Ringage, you know, the one of those that's European. Yeah, and some of those standards. The guys who do, you know, Locanet, you know, they've been working on a bidirectional standard. They have it, and the British are ratifying that into a standard. If that can come back across the pond and advance in DCC, and Locanet is trying to make that happen. So I think that's going to happen.
Digitrax does have that with their transponding, but it's very problematic to make that work.
But the guys doing it in you know,
use a thing called Railcom.
Yep, that's the Locanet guys that done that, and it's great. It's just extremely expensive and entirely proprietary, and you have to have all their decoders and all your stuff. But the British have ratified that as an extension to the DCC system under the British standard, and a lot of that stuff has been going back and forth. So we developed the U.S. NMRA ratified the 9-pin DCC standard. The 21-pin was first ratified in Britain and came back over here. So there's this back and forth that happens with these standards. We ratified the 9, they ratified the 21. The 21 came back over here. So if
our version of the 21 is different.
Yeah, the British 21 and our 21 there's some subtle differences there that have become problematic, but it's all because we brought their standard over and we made some changes. But if that bidirectional communication part of their DCC standard will get ratified by the NMRA, then we could have bidirectional communication in DCC soon enough. And DCC is perfect for locomotion control. It's just way too heavy for turnouts and signals. We just don't need all that.
Well, Mike, correct me if I'm wrong, but some of the TCS decoders actually have Railcom in them, right?
They have the Railcom chips in them, yeah. So
is that all of them, or just?
I would say, I think basically the whole product line, except for like maybe the Z2 or something that's really extremely small. And the thing is, I think what they want to do is just to get their toes in the pond. I mean, if you look at Railcom, what it really is, it has a little section of the DCC frame where it can do the Railcom stuff, or it does the bidirectional communication. So essentially, it's kind of like a rider onto the DCC spec. So that's where it has like a little window in the frame.
Now, where it can do all kinds of interesting things because it is bidirectional, and it can be set to monitor how long the locomotive operates, so you can actually have it say, if I'm using this much, power for my locomotive, I can only go so far before I need to make a fuel stop. So it can
Run
be
out
set
diesel.
up. Yeah, it can set up. I need to stop for water. I need to stop for coal. I need to stop
Mhm.
for diesel fuel. I can say the engine's overheating. I mean, it's got a lot of interesting possibilities, and I hope someday that gets adopted in this country so that we can start using it. Because there's no commercial transponding hardware in the U.S. that works with DCC detected yet. The only viable uh, transponding system like Railcom we have is the Digitrax transponding system, which pretty much everybody knows is if you get it to work, it's sort of a miracle, because
Yeah.
that's how the soundtrack. That's one thing why soundtracks hasn't sold a lot of soundtrack systems because it relies on sending the sound from speaker to speaker to using the Digitrax transponding system.
Mhm.
So it's
Yeah.
a little on the problematic side. If you can implement it and make it work, it's cool. I mean, it does what it needs to do. It can
Mhm.
tell you where your locomotive is, what your locomotive is doing, bi-directional, so you can send information back and forth to the locomotive.
Right.
And
But
then the soundtrack system is designed to say, oh, my locomotive's here, and then this is the locomotive that's here. It's beyond lock detection because that just says a train's there.
mhm.
The transponding system says locomotive 1361 is here, and since the soundtrack system says, oh, I'm playing these sounds for 1361, it knows to send it to the speaker by that transponding node. That's how it works. And when the NMRA convention back in the 90s, when it was at Valley Forge, they demonstrated that back then, way before it ever became a product. I mean, it's only been a product in the last few years, and I really don't know how much they sell it.
Yeah, it's funny. It's funny how like the product, the product productization of different neat ideas. It just takes a while to develop and get that critical mass. But I mean, the one thing too about Railcom, like you were talking about the whole idea of, you know, the imaginary fuel level of a locomotive, the water level, the coal level, when you have to go into the shop, that kind of thing. With Railcom, you could actually simulate that probably today with JMRI or if you had a DCC command station with an Arduino where you could actually program stuff like that there. So you really don't need Railcom for that. But where Railcom would really come in handy is in terms of doing stuff like if you had information on the back EMF
Mm.
or if you had like a sound decoder where you could actually, um, do some extra notching if you needed a certain spot, or change the characteristics, or even if the locomotive itself's overheating. I mean, literally overheating, not pretend overheating.
Yeah, yeah, yeah.
It's burning itself up. Just like that one locomotive I had where the motor was like burning itself up.
Oh, that MTH one, right?
Yeah, right. I mean that motor was shot. I mean, it's something like that. Would said, "Hey, yo, dude, you know, I'm gonna be smoking in the next half hour."
Yeah, I mean, I think we'll see some interesting things from that down the road, but
Hmm.
I mean, it's a good thing the NMRA took on the LCC standard and finally got it going. And like Andy mentioned, there's still ways to go with the hardware side for the throttle control. But I think we got a nice, great future here. So, Mikey and I and Chris and Andy will keep our ears to the ground, and I'm sure we'll touch, sometime in the next year or so. We'll probably touch back on this again and see what exciting hardware is out there, and hopefully we'll have something to demonstrate and show off how this stuff all works, and maybe, like we're working on the JMRI episodes over the summertime and everything, that we'll be able to do something really informative on how to do LCC and how it all works. So stay tuned, folks. Well, it's about 11:08, so I think we're going to wrap up here. We just got one quick question here that the Redneck Railroad has asked us. What do you guys think of the battery-powered locomotives that are, the independently powered ones? Yeah, I mean, here's my thoughts. Um, until they really get powerful enough batteries in small scale that you can use an HO that'll last for 3-4 hours operating session or even a 2-hour operating session, it's not that viable yet. Now, for the large scale guys like G scale or even somewhat an O scale, you can get some pretty good sized batteries that'll last fine. I mean, G scale locomotives, a lot of them are designed so you can put like a gel cell battery in them that would last for days, like a mini car battery. You can't get that kind of power in HO scale yet, where unless you want to get a big LiPo cell that'll fit like in a boxcar that you plug into your locomotive to power it. So it is possible, but because of the attendant technology issues with having a large enough battery, it's still not, that viable yet. But it may get there. It may get there. So we shall see. That's another thing, if that becomes a technology hot point, I mean, Mikey and I and the guys here will certainly be talking about it at some point. So, just stay tuned. Check out the show.
Well, Barry, here, I always come up with these weird ideas.
Yeah. You're like
So,
a weird idea factory.
Yeah, absolutely. I'd have the weirdest one yet.
Oh, God.
Solar power, solar trains. Now get this. On eBay, there's this 3-unit bullet train, little toy you put together.
All right.
Runs on a solar panel.
Interesting.
Okay, and the wheels are gauged to HO. Now, I mean, it's the wheels are crap.
Right.
You'll run in a circle track. The funny thing is, right? If you put it out on a circle track in bright sunlight, it runs like a bat out of hell. And if you basically just have it run around the circle, and the darker it gets, the slower it goes.
Wow.
But if you could use that solar powered train and figure out how to get a control system in it.
Oh, I'm sure you could, because if you can get a small enough solar cell.
It would have to be CMOS though. I mean, we're not talking a lot of voltage or current with that solar panel.
You're right. You would have to go with CMOS control chip because of the low power.
Right.
And,
it definitely would have to be a low power.
Yeah, I mean, you really could use the solar cell to charge a small LiPo battery and then power the system from the LiPo battery.
Mm-hmm.
But that, you have to still have, the solar cell has to provide enough capacity to keep it running should the battery drain. So the battery's there just as a buffer.
Yeah, well, the thing is, right, all the solar cell has to do is keep the battery going long enough.
Exactly,
right?
Yeah.
So if the battery's good for, like, say, an hour and a half, and the solar panel, if you have it attached to the solar panel, and that gives you an extra half an hour, but now you got a 2-hour runtime.
Yeah, I mean, that's an interesting. I mean, I don't think we'll see that adopt into our world. But for like an interesting tech toy for kids and everything, that's kind of a cool concept.
Yeah, I mean,
there you go.
On the muck with.
Hide a solar cell inside of a Vista Dome car so it gets light in there to power it, and you won't see it.
Hey, the solar panels are nice glossy black. That would be a nice roof too.
Oh yeah, as long as you can't really see yourself
on your cracked passenger train.
There you go.
Keyword there being crack.
We've now officially derailed as usual. So, folks, thank you for watching tonight. Hope we put some interesting thoughts in your heads. Provide you some interesting information in our crazy little tech world of me and Mike's and the crew here. So, hope everybody has a good night. And please don't forget to support, YouTube model builders. And go to the website and go to the EMAG link and subscribe. That way you can get your information when the EMAG's published. But we're eventually going to be using the same mechanism to put out stuff about other events. So, make sure you go there and sign on up. And let me share this here real quick. Back to my screen here. Okay, present to everyone. So, don't forget, YouTube Model Builders is your source for free model railroad information. I just mentioned we have a free online magazine, the eMag, and the issue of this past month in March. It's all on signaling. Fascinating articles, 55 pages of good information, no ads. And we have our live chat presentation hangouts like we are here, and the ever popular YouTube Model Builders live show with myself, Bill, and the other members of the crew. So make sure you guys check us all out and keep on watching, and we'll keep providing you information, try to make your hobby a better thing for you and for everyone to enjoy. And I'd like to thank those that attended, some questions that came in. So, Redneck Railroad, I'm glad you guys got some information. Dwight, thanks for hanging out with us and asking some questions, and hope you got some information. So, and Johnny, yes, Peaches is at 462 Pacific. She just huffs good. Poor old girl just chuffs and chuffs along. So, everybody have a wonderful night. Mike, Chris, Andy, everybody, thank you very much. And we will see you guys again soon. Take care.
Thanks, guys.
Yeah, very good job.
All right, thank you very much.